Hello, this is the final video for Group L of UC Berkeley's CS160 User Interface Design course project. Our project was Alfridge, a connected device experience between a compartmentalized smart refrigerator and a mobile companion application. We'll start by introducing our target user group. They're busy young adults, so they're always looking for ways to save time. They're omnivorous, so they frequently move food around the refrigerator to defrost. They're single, so they don't have a lot of outside help. And lastly, they cook regularly, so they have a lot of interactions with their refrigerator. The problem that we noticed through our contextual inquiry was that people waste time and food through unnecessary interactions with their refrigerator. Examples include not knowing contents of their refrigerator and buying excess food, forgetting to defrost food and having to return home to do so, scouring the refrigerator to determine things to buy at the grocery store, and throwing away expired foods due to forgetfulness. We determined that existing smart refrigerator applications do not solve the problems that we see as most critical. These applications rely on tedious manual input, and the software is mostly disjoint from the hardware. Our solution to our target user group's problems is Alfridge. We focused our mobile companion application around three core functionalities. 1. Users can alter temperatures and defrost compartments remotely. 2. Users can view, search, and store items in the refrigerator. And 3. Users can create, view, and edit grocery lists with suggestions based on recent interactions with the device. Here's a walkthrough of our final interface, starting with the mobile companion application. Here you see the home screen, which displays the refrigerator compartments. As you click into a compartment, you get an overview of the name, temperature, and items within the compartment. This is also where you can defrost the compartment. As you do so, the status of the compartment changes in the simulator. Our interface uses a central navigation bar for various functionalities. I'll move on to the Items tab, where a user can remotely check on refrigerator contents. Here you see a list of refrigerator contents, and there are various tabs on top for sorting items in the refrigerator alphabetically by recently accessed, quantities, and expiration dates. The user can also use the search functionality to search for an item, for example, milk. Moving on to the Grocery Lists tab, the user can view past grocery lists sorted by those that are recently accessed. When you click a list, you can check off items that have been purchased. You can also search for specific lists, for example, Trader Joe's. Another functionality is creating new grocery lists. When you click on the plus icon, a screen appears with suggestions from the refrigerator based on recent interactions with the device. For example, expired foods or recently accessed foods. After clicking through suggestions, the user can then add a title and more items and click Done. Now, this grocery list is ready to use. Moving on to the simulator, our device simulator consists of an item sensor and a temperature sensor. The item sensor simulates the refrigerator, sensing all the items, quantities, and expiration dates of the items in the refrigerator. The simulator has its own interface, which you can set to one of the presets. You can also add an item, which is now reflected in the application, delete an item, and you can see it's now gone, or clear all the items. The temperature sensor simulates the temperatures inside the refrigerator. As you can see, as I change the temperatures on the simulator, the temperatures on the app change with it. Throughout the semester, our group encountered several implementation challenges. The first challenge was learning to use a new platform, Kinoma.js. We also spent a lot of time on cross-device communication and automatically syncing details between two devices. Our most interesting challenge was creating a simulator that could simulate the refrigerator sensing all the items, quantities, and expiration dates in the refrigerator. We built a custom pin simulator with its own interface for adding, deleting, and setting items, and even received feedback that it was probably the most complicated pin simulator ever built with Kinoma Create. We performed several rounds of user testing this semester to improve upon our prototypes, and learned a few overarching lessons. These include small changes make a big difference, users notice a lot more than we do, and people like to click random things. Based on these lessons, we decided to guide our interface to be minimal, clean, and intuitive. These guidelines can be seen most notably in our compartment view screen, where we eliminated several unnecessary features, and in our suggestions page, where we split an originally complicated one-screen process into two simpler steps. As a final conclusion, we were able to implement the three core functionalities of our application this semester. We also created the architecture for the interface, implemented cross-device communication as an Internet of Things project, and implemented additional features such as item sorting and search functionalities. Some improvements of current functionalities include making the item displays more visual, since people are accustomed to visually searching through the refrigerator, and improving the search and suggestions functionalities. For the future, more functionalities to implement include expiration notifications, setup refrigerator configuration, device-specific troubleshooting, and refrigerator usage analytics. And that's it for our final video. Thanks so much for listening. It's been a great semester.